All right. Is that a voice crack? I don't know. Anyways, this is a weird, different video, a lot looser than what you're probably used to seeing on this channel, and that's all right. I really just want to try solving an interesting problem in Jai, um, and then kind of record the process because that'll be an interesting video, or at least fun to watch, maybe. So yeah, if to sort of describe what's going on, I was going to say if you don't know what's happening, but you wouldn't have any context for what's happening. Um, yeah, to explain what's happening, basically, I want to see if I can call Jai code from Go. I already know I can do this, so I'm trying to make it a little nicer by having something that auto generates sort of a Go eligible function, or essentially like a C calling convention function from just a bog standard Jai function. Right. So for instance, I have this window open from the window creation library module or package or what the fuck they're called. Um, yeah, so I just want to be able to do this. Say, hey, export something called window open, take in this thing called create window, and then it'll go and look at this thing called create window and then generate a C-call function that looks like this that converts it correctly, right? So strings would be like 8, default arguments, have their defaults because you can't have that. Jai, or maybe you can't have that in Go, or maybe I'd generate like EX that, you have these, and then these would use their defaults. I don't know, but I just want to test this out. I think that would be interesting. So this is as far as we've gotten so far. I just started 2 seconds ago, right? So we make a string builder, get the procedure from the argument, and then verify that, have any weird stuff going on. And then that's about it, right? So now I can print the info. See a bunch of stuff. So procedure, type of procedure, blah, 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 English. Type info procedure only has argument types, return types. That's all I really need to do. I kind of don't care about the argument names right now. I kind of do, but at the same time, I don't. So can I even get those? I don't think. Got argument types. Keys and that star, boom. Yep, so that's just going to give me the type info. So we're not going to have, argument names, but that's okay. Just going to do this. So we need that string builder. Off append to the string builder, a little opening paren after the arguments, do a little closing paren if it return types. Luckily, Go can have multiple return types, so this would actually work. These, a little arrow action. That'll do that. And then we have to generate the body. Okay. That might be a problem. Because we can't get we won't be able to get this create window. We'll figure that out later. That'll generate the body. This needs C call. Boom. And then one little easy thing, and that's context, and we'll call this CTX. So, boom. Just like that. We're not going to handle return types right now because I just don't care. Actually, I guess we could, but I don't care too. So that compiles, and let's get. Oh, we need the door. Now, also need a semicolon. Cool. Now, context isn't declared, but this is what we're generating. Procedure. And so let's do this argument type stuff. So I think I can kind of cheese this right now. Builder B and this. It. One up. Now if I do that. Ah, darn. I was really hoping that would. I think. Oh, wait. Can I do get type? Yes, I can. Because these are type infos. So that makes sense. Why is that? Is that on okay? Oh, because they actually need. Okay. Just gonna do a old fashioned arg boom. That. So we'll do that. Fixed size arrays cannot be passed directly as arg call procedures. Okay, to make it clear, the callee can modify the array should declare an argument as a pointer to a fixed size array or type. Size arrays and C's. The callee can modify the file fixed array argument. Okay, so let's just do footer like that, and then do just a little one of these. X need footer, or else nothing. Now we can type array. Array. It's flags or like a type. Yeah, array type. Fixed. Boom. Cool. So that's actually good. So now we're passing it to a pointer to some fixed size array. And I guess we could also change the type to then be just like a pointer to float 32. I actually kind of having this number. Cool. And then we just got to do the same thing for the args here. This action in. Count. Builder type. X once again. Cool. So now it should be our return types too. Let's need. Oh, correct. Cool. At least now we should get, void pointer. And we don't actually need the little parens right here. I'm not going to add here in Shyland. Right with me. Cool. We'll just add this little space right here. There we go. Now we need some context. So let's just make this like that. This would get filled in here. Matter. And now we get not all control as return value, which is good. That means we're actually doing thing. So all we really need to do is do a nice little. Well, there is a slight problem, and I'll talk about that in a sec. Right, but we need to basically get this function, name of this function. Don't know if there's a way to do that in the compiler. I mean, there is another way we can do this. Actually, be a better. This we can do proc code. Now we can either get nodes proc expression. That assert null. It's a code node, and that should probably be code ident. Sure. Ident root. Ooh, that is kind. Ident. Okay, cool. So that's actually fine, and let's just comment this all out so we can get this working. So we have a code ident. That's going to have a name, and then a resolve declarations. Assert ident.resolved declaration. null procedure, boom. Solved yet. Ident. Cool, so that does actually work. Decl is ident.resolve declaration. That should give us a code declaration, which then type instantiation, type instance, which then we can check. So we just proc t decl.type inst cert decl.type in. Oh, we did add certs in because it makes our lives easier. And look, we just caught one. So that's actually good. Why is that the case? I don't think code's a scope. Okay, so decl.type inst. What about decl.expression? Is that correct? Okay, so we can use that. Experb. And then this should be, I think, code procedure header. Cert procedure header. Expected type must proc must argument must be a procedure was blank. A kind. Now that we have the code procedure header, actually gets everything that we want. So we should be able to get the resolve type yet. We don't need the body. I guess I can kind of do this the same way. Proc T thing. Wow, there's a lot more flags in here. Let me just print them. It's been a while. Expert procedure flags. Zero. Nice. Okay, so we can kind of do what we want. What we did earlier. So proc dot procedure flags equals 0. Proc dot procedure flags has no context. Oh, and proc ident. That this won't have no con. I think it just heard no context. Here. All. Earned value. Okay, so we actually don't have access to that in type info, which is okay. But now we can go back to doing the same thing. So now we just need to change this up a little bit. So rather than info.argument type, proc.arguments. Comment all that out. Instead of return type, so it'll proc.returns. Oh, and this is yelling at proc ident. Print that, or is that just the it's the type? Cool. So now that we have the arguments, we can do argt dot. It's gonna be station, so that can be type in. Now we can actually assert the type in. I think it should be none. Check that. Nope, it can be null, which is super cool. It's going to be kind of hard to get the type of this now. Actually, we could do this. I think might solve my problem. It dot type in. Oh, let's see. Nope, still there. Could I do something kind of weird? Maybe I could do something a little weird, actually. Right. If exists, proc ident. Its wait for expression will be proc ident. Something like this. Oh, hash exists. Query for exists must be separated by an identifier, a series of identifiers separated by. Let's see here. Okay, so we might be able to do something like this. Return another run like this. I think the only downside is now we'll get that like stack frame error. No, we don't. Nice. Okay, wait a second. Let me just double check that in here, assert it dot type in null. Why is it still failed? Oh, because I need this to be a macro, like insert the proc ident. Insert proc ident. Okay. How am I gonna do that? I guess I can do ident is insert proc ident. Now I can do ident. Yeah, that's annoying. We'll make do, I guess. So what do we have? We have a code declaration. One, we get a type inst. Excuse me. Yeah, it's a bit of a problem. If we can't get the procedure type, it's not defined yet. It's kind of annoying. You just see this. Boom. Enter declaration, type inst. Okay, so type inst is only null on some of them. Width, height. So window X and Y. Window X and Y don't have. Oh, okay, that's why. I know why. Anything with a default argument. So like I get window parent. Yeah, because parent has it specified. Window X and Y are both inferred, same with background color. Okay, so we really need like a type info. Yeah, arg info. So if it dot type in to null, then we can get the type inst. That should have a yes. That really quick. Code type inst type valid expression we don't care about. We just care about. Okay, so I think all I need to do is just assert it.type int.result not equal to null. Now do arg in that. Otherwise, we need to get arg exper dot expression, and let's just set a little dot expression. Oh, boom. So now if we get that, we need to type of it. It'd be kind of a pain in the ass, except it's totally not. Now we can just do arg info, arg exper dot type. Now arg info, boom, and there we go. Now we get integer, string, integer, pointer, array, integer. That's all we actually care about. So now we can go and do what we did earlier. So arg type, that's arg type. Pointer is false, and this is actually called arg info. Boom. Pointer, then boom, get type arg in. If arg.argument count. All right, what do we got? Hey, and we're back. All right, so now we got all these again. I mean, we actually have the name now. We could just use that, right? We could just here it.name. Is it not name? Oh, whoops. Oh yeah, we don't need index anymore. I gotta delete the index. Okay. Nice. Now we got with height, window name, window X, all that stuff. The only thing is we need to convert things like string. We convert, already convert these arrays. So I mean, I guess we could actually do something like this, where we go if arg info dot type is string. Yeah, I like that. If arg info dot type array, boom, string arg info I guess arg info literally cast type info to pointer to U8. And now that'll be a pointer to U8. We can just do that. Cool. So now we got our arguments. We'd have to do the exact same thing for return type, which is kind of a pain in the ass. Yeah, let's make a quick like get type from decal. Type decal code declaration. This turn info. Boom, 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 boom. So now we can just info get type decal. Yeah. And what we could do here actually is we could make footer T is we could do get our type info void that footer T has to pointer for T dot pointer to equal. That's fine. Work. I don't need this anymore. That'll just be a pointer now. Archetype. Okay, so type. Get type. I thought it takes a type info. Oh, right, because we're returning type info. Just need to do decal. Boom. All these it's need to be decal. This is just that and that. Now, do the exact same thing for returns. This, if I can copy and paste properly. Returns. Boom. Ret type. Why did that? Oh, yeah. We just need the type. We don't need the name anymore. There we go. And we don't even need returns.count. There we go. So now we got a C, a C-ish function, or function signature from the type info, which is really good. So now all we need to do is we just need to generate a call. So if proc.returns.count, then we have some return value, and because Jai, it's kind of weird, we can't just we can't just do like return create window of all this if it had multiple returns. Also, why is this returning a pointer to 3 floats? What? Let me fix that part first before I yeah, get type from decal. Let's just make sure we're not using anything from outside. Okay, we weren't. So we get the type info. Result type. If type is an array. Pointer. Info. Pointer info dot pointer 2. Why is it returning an array? That make no sense. Go to create window. That's returning a void pointer. Basically. So we get the info. Check. That. Why are we hitting array? Huh? Why are we hitting array? Type. Okay, yeah, pointer. We hit it. Yeah, we hit array here. Right, because it's array. Pointer. Is it because okay, I see exactly what happened now. I'm getting the type info, which turns me type info pointer, but I'm not creating a new type info. So what I'm doing is I'm overwriting any type info pointer or the type info for void pointer exclusively with the type info for, float 3. So I need to do something like this, type info pointer. There is a slight problem that I need to set the tag. Okay, so that would be what? Oh, runtime size. I guess I could do pointer info dot type pointer. And then pointer info dot runtime size. We'll just do size of void pointer to make sure that's all good. My dog's playing with a toy in the background. I don't know if anyone can hear that. This should be correct now. Oh, and it's not. We get a type info pointer. Set the type to pointer. You know why now? Because get type is going to fail. Yeah. So that's a problem. Is that get type is now not going to be correct. Because, yeah, only valid on type info is created by the compiler. I think there might be a way to create a type. Don't know. You might be able to put it in the type info table. Runtime type table. Important if you run dynamic specialize this one, validate the results of the got. Okay, so what we could do, I wonder if this would work. If I do something like this, if I do like get type info or get runtime info, runtime info, boom. Okay. Print this out. This should give me a struct that then has all the pointers, or sorry, all of the arrays. Sorry, what am I talking about? All of the types in the program. Now I can do existing types, array of what? Type info? Yeah. Dynamic array, type info, array add, existing types, type table, I think, type table, prefix of course. That's, yes, okay. We got that. Doesn't return me a pointer, though. Ah, wait, I have an idea. Because I think this, does that return me a pointer? No. Yeah, I don't think I can do this. Right, I don't think I can do this. Pointer info. Runtime info dot type tape. Types. Pretty sure that won't work. Yeah, that won't work. It'd be very funny if that did, though. I wonder, can I do like get types table? Yeah, I can do that. Yeah, I don't. I think it's checking like if the if the address of the type I'm passing in like exists, or there's like some like maybe internal type tag that isn't here, or it's like that's like hidden. Maybe that is what the compiler's checking. So can't do that. What I can do is I can just return this. I can just do something like this. Still fine. And then instead of doing get type, printing that directly, I can do something so, which I probably actually want to do. Type to, wait, is that gonna work? Arg type. There's no way this would work. I think that would suffer the same. No, it totally works. Okay. Well, we're just going to do that. I forgot print type to builder actually works in type info types. Only downside is for structs that are polymorphic, which I guess would mark that the procedure flags would be polymorphic, so we don't actually have to deal with that. Basically, as you can see, like with this space here after the 3, this is valid Jai syntax, but sometimes, for instance, with like callbacks, or just it won't print the type correctly. So I'd actually want it to do here. That's like, this might, right, something like that. Something, probably want something like that. But okay, now we got that. And now we can actually, go and generate everything, the body. But before proc.returns, proc.returns, array print to builder, like ret boom, and that'll be it index, and then we, if it index less than proc.returns.count minus 1, and boom, get that comma in there. And after this, and that bad boy, and now we can just do our call. Maybe for proc.arguments, boom. Little problem. Actually, no, not a problem. Never mind. Ignore that. Print to builder, boom, 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 like that. A little append right here. Don't forget your semicolons. Programming world, proc.name. Could be. Oh, we forgot the tabs too. No, we can't forget tabs. Oh, who am I? I guess we just need to do. Yeah. Okay, so we were generating the call, and now in here we just do basically what we keep doing, and that's just gonna be print to builder. And I'll show you a problem that's about to happen in a second. This, we can just append it dot name if x less proc one. Boom, like that. This. Now you'll see this works. Well, first off, we need to return, so we need to do another if proc.returns.count. And I mean, we can make this nicer. We're just trying to do this stupid thing to get it to work. Who actually cares? Print to builder. Boom, 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 boom. Return. And now we got to loop through the returns one more time. And do that. This. Yep, just like that. Append. Boom. Like this. New line. And then we get the return. Okay, cool. So that's correct. This is all fine and dandy. But you notice the problem is that window name, right? Mismatching levels of indirection. Type wanted string, type given, boom. Right, that's a problem. So there's a few things we can do. We really only have to do it here. So rather than just appending the name, we say if it dot type, because who cares? We'll just get it again. Get decal it. So we can do if arg type dot type is case string. If it's a pointer and it points, so if it's a string, we got to do something, and if it's a pointer, we also do something a little fancy. Otherwise, we can just append the name. So we're going to do print to builder, and that is going to be toString. Boom. And that's actually all we need to do. So the name. Right for that. Now we're not doing it for any more pointers, so that's why it's failing. Right, but we just need a little toString, and that'll do like a cast a string, or sorry, it'll take a U8 and then call like C style strlen on it, right? Which is just look for a null terminator. That's all good. If it's a pointer though, and we get like putter info type info pointer, and then if pointer info dot pointer 2 dot type is array, because that's all we actually care about. If it's an array, otherwise we can do an append it name again. Then we need to make an array. Well, kind of a problem. Let me double check. So array info array pointer info dot pointer 2. Are you? Oh, right. Arg type. And so now we just need to check if array info array flags. Oh no, array type. Array type goals. This will be fixed because that's what we actually care about. Everything else is not valid. We can actually do assert info dot array type is fixed. Dynamic arrays and views are not supported right now. Cool. Now, all we have to do is kind of goofy, but it'll be all right. Print builder, boom. We can now do this in Jai, which is very nice. I like this a lot. So we're going to do the data is boom dot data. Actually, no, we can just do boom. That'll be it.name, and then count is this. So what we can do here is, and actually we need to do one more assert because that'll be array count. Boom, assert array count 1. This will now be it.name array info.array count. Boom. So why is it yelling? Oh, that is annoying. Right, so this worked, right? Data background color RGB, count 3, boom. But this is our little, we're hitting this instead of hitting string, so that's a bit annoying. So what I think I want to do instead is I want to keep this. I don't think there's a type info string. Is there? There is. Um, yeah, I guess you know what we could actually do. We can delete this. This will break now, because now we are putting in the word string here. Um, rather than printing it like this, we're just gonna do if archetype.type is string, boom. Otherwise, boom. Append u8. There we go. Then we got window name u8. Do string window name. Why is this complaining it is attempt to match unary array type that is not an array view. Unary struct literals pass to array view. Darn. A fixed size or arrays. Okay, so we can't actually do the thing I want to do, but that is okay because what we can instead do is something a little disgusting, and that is just going to be this. So we can do print type builder array info dot element type. Kind of wish I didn't name it array info. That makes it a lot harder to freaking type. But now we can just do for array info dot array count 1 0 to that. Print to builder, boom, and that'll boom, boom, like this. That there. It index less than a info dot count -1 append. You know the classic, the thing we keep doing. And now all we need is it dot name and it index. We're just gonna actually pull the values out of. Oh, what not it name? Because this needs to be like. We're gonna overwrite that. Okay. Oh, and I forgot one quick thing. Append. Boom, boom. Or just add some spaces to make it more clear, make it a little better. Okay, so now we're getting closer. Data. There we go. So now, this is really goofy. Actually, what am I doing? If you may have noticed that I just did a lot of stuff I didn't have to do, like an idiot, then yeah, good on you. Because I can just probably do this. Dot star. Id dot name. Hey, look, I can just do that. Okay, let's just go and do that instead. Nice. Rather than having to spread the freaking array, index it, we can just reference it. But nice. That's basically working. Yeah, that'll generate a procedure for anything. Do I want to be kooky with? Do I want to be a little goofy? Be a little guy? Not really, I guess. I was gonna also generate like the I was gonna generate the Go like function signature with this. Um that'd be kind of fun. I'll also do right like if it makes like a note here that's like no, because then I can't really do that. I'd have to like make a comment that's like funk. Oh wait, yeah, how would that look? I have to look something like create window funk 64 height 60 uh 8, or in this case probably make it like x 60. Yeah, I kind of don't want to do that. I'm all right. But there you go. We have successfully now generated a bunch of stuff. So let me just test it out in another function. We'll do it on inputs. This will be window update. And that'll be. What did it generate? That looks pretty good. Yeah, it doesn't return anything, and it just calls. Right, it takes no arguments, doesn't return anything, and it calls update events. Let's do a little more fun one. Oh yeah, get dimensions, because this has a lot of. So we guns alignment. You got to align your code. Why does not? Procedure calls marked. Oh, but has multiple return values. Right. Can't. Just because Go can support it doesn't mean we can support it. So what we could do is we could make it a struct return type. That wouldn't be too bad. Right. So imagine it would generate something like this. Right. And this. And then all we have to do is if we have multiple return types, we just wrap it in here like this, and then that should be fine. Also, this is working nicely. Slight downside on that, I don't know if pure Go in Go can do multiple or do like struct return types. I don't know if you can do struct return types. Test that out really quick. Here's like the little test program I have to do and check if this works. So let's do test or I like thingy. It's gonna return a foo. Type foo is a struct and that has a 64 and a 4. Let's go and find that here. Thingy. Let's call it here. So thingy. That out. Run. That will fail to compile. Specified procedure cannot be found. That is actually okay because here program export thingy. And that a foo. Foo. Speed. Okay. That guy right there. Cool. That works. Should return type. Damn. Okay. So that sucks. We can't do multiple return types or multiple return values, which is okay. What we could do though is instead of that, and it's gonna look kind of ugly, is we could do something like right. So it's like out. This is 1, 2. We could do that, and then we do it all but the last one, right? So this would return ret 4. Then it would do like ret 0. Yeah, that could actually work out 0, or if it has a that, so it'd be 0, ret 0. Could do this. That would give us a lot of control, or not a lot of control, but it would make this work properly. The only downside is when you're calling it from Go, you'd have to like do a lot of stuff. Have to go. You'd have to do what you'd have to do in C. So I guess it's no worse. So we'll just do that. So how can we do that? So we just do check the argument here. So okay. We only want the last one. So we want to do rets type info proc ret. I guess I don't even need to do that. Literally just do echo proc turns proc dot account -1. We only want the last one. That's all we actually care about, which simplifies this because now we don't care about that. Nice. Good. Too many wires. Got that. Again, now this will be for our assignment. I want to do if proc.return -1 greater than 0. We can now it index less than proc dot, and then this needs to be 2, which is very gross. Kind of hate it. We can actually simplify it a lot more by doing it. So we're gonna do proc ret type info rest ret, or we'll call them out param array of type info. That's actually just going to be proc.returns code declaration. So that's fine. What we can say is we can say if out params dot count more than 1, proc ret is type from decal 1, boom, out count 1. That's all we actually need. Right, so we only want to do if it's more than 1, if it's 0, or it is yeah, if it's 0 or 1, we don't actually want to do that because we. So now we just check, hey, if proc ret not equal to null, then we just do this. Boom. Proc ret. There. Bada bing. And then once again, we now we just need to check if out params dot count. Then we can do out params, and then that would be that. Because now, well, we have to do this before we finish off our thing. Yeah, which is kind of. Wait, what? If proc ret not equal proc.return. So, oh, wait. That's actually what it is. That's a lot better looking. If out params. Okay, so if it's greater than 1, else if out params 0, I guess we can just do equals 1. Proc ret decal out. I guess we just want to check if it's more than 0. Yeah, because then we don't actually care. If it's we don't actually care in that case. So now when we're making our out params, we need to check if this is then out count 1, which is now correct. Unclarified ret 0. Okay, so we need this. Proc ret not null. So that'll always be ret 0. So we can builder ret 0. Like that. And I guess I can just do if out. We're gonna kind of make this gross. 0, boom. We're not trying to make it pretty. We're trying to make it. Why is that? Parse expression. We got ret 0. Oh, because we're doing. Actually, why even generate a return argument for that? Like that actually doesn't really matter. What we could just do is we could just do this, and then before we generate the call, we just say, hey, if proc ret not equal to null, do a little append of the word return. Boom. I think that needs 2. right? That's that correct? Yeah. That would be that. I guess. Well, because we need our out param. We need our out params. I guess I could make this a lot simpler. I think about it. I kind of did something stupid where I could have kept all this the same, right? So we just keep our same old like ret 0, ret 1, 2. We only return ret 4. And then all of these besides the last one. Yeah, that's probably the better option. Let's just go all the way back where we were at the start. Right, and so now, so when we're making our return string, go, hey, we have proc.returns. The one that we're returning should be one less, or should only be the last one. Last is proc.returns. One. And then we can also do this up here as well. Proper thing, but I'm not going to do that yet. Last. Boom. So now we'll get too many return types, but that's fine. Right, because now we're returning a 5. Cool, so that's fine. All so far, and then we're going to do all this stuff here, and then we generate the return. Now we just get the last one again, like so. That don't have to generate all this stuff. And we can even just do this. Actually, this proc.return account. Not even using the name. Ret. Yeah, ret. Boom. Those, get a little one of those, and now that works fine. The only thing we're not doing now is doing the argument stuff. But now this is correct. Right, and so all we need to do is we need to get from 0 to ret.counts minus 1, ret.count minus 1. Yeah, which is fine. So what we can do is after we do the arguments, after we do the main arguments, we're going to do that returns account right here. And we can do for I dot dot I 0 dot dot proc dot return dot count 1. Give us all but what we want. Now we can do out. Boom. Like out blank. Decal. Proc dot returns I dot name. Actually, no, I just type out type proc dot ret why is that? Oh, because we didn't builder. Duh. I didn't do the thing. Type. See, and the best part about this, by the way, this is all running compile time. We can be as stupid as we want, really. It's never really going to have an effect on us. That's a really nice thing. Oh, and then this little it less proc.returns count minus 1 penny. Boom. Like so. And now, these all need to be pointers. Duh. One of these. Make it easy. We got out 0, out 1, out 2, out 3, and then we need this minus 2. And this will also be minus 2. Minus 1. Minus 2. 0 proc.count. That's not correct because that'll give us the fourth one. At 4. What am I doing? Proc.return count. I wish I could do like the Odin. I do -2 though. Why does that? Oh, because I added a little comma right there. If proc.returns.count more than 1, boom. Now we do that there. This goes like that. Gotta put right ifs, right? So we got out 0, 1, 2, 3. Cool. And then we're returning 4 here. So now before we do that nice little return here, all we need to do is for proc.arguments.count. If proc.returns.count more than 1, so it'll for proc.return.count -2 builder, boom. So now it's going to be out.star equals ret. So out number ret. That's just going to be I. Look at that. Boom. Out 0, 1, 2, and 3. Return 4. Get dimensions works. This still works properly. This still works. What is another crazy one we can check with? Dimensions. Pointer position. That's... Yeah, I don't know. I could have done names here, but don't really want to because then it's going to be... I just don't care enough. Let's see. What's another library we can... I like... what's a fun little library we can bring? Maybe from input. I mean, I guess I could test. I'll test really quick if it returns something that we know. Construct. Maybe an array. I don't know for a fact. I mean, an array, it's just gonna be a pointer, so fine. Bit tough. Yeah, maybe we'll do hash table. Let's see. We're never gonna use that, but oh, that's also polymorphic, so we actually can't. Yeah, let's just do like failure. Failure case 1. First off, it constructs int and a y int. That return 20. One, boom. So that'll fail, but that, oh, yep. So here's a problem that we saw. It's that, where is it? Oh, so we can't see. Oh, yeah. Anonymous struct prints it incorrectly. So let's just handle that really quick. We could handle that in here and then it'll handle it everywhere because well, we might want to support structs for arguments, but we don't want to support them for types. So let's do that here. Where do we check last? We kind of want that for all of them, right? No. Yes. Any return type. So assert out type dot type not equal to struct and out type dot type to array. Boom, and then we here ret type that. Say structs arrays. Easy. Structs and actually they kind of are. Why am I making that? I just can't. Oh, but I guess if I'm using pure Go, I probably can't. I probably can't pass them or return. That's going to be a bit of a pain in the ass, but that's okay. Yeah, I guess I could do a similar thing, like the type spreading or like the spreading where we make outprint. I'm not really gonna do that right now. Int return 0, boom, that'll work. Failure 1, H64. The one thing we do want to do though is if polymorphic. Nice, we do get procedure. Not have flags. Flags. Rock dot for flags. Right, polymorphic. There we go. So it can't be polymorphic. That is perfect. Say maybe it takes a pointer, returns a pointer, return that. That'll work because that's just gonna void pointer. Safe dot go. So that's all working. Yeah, let me double check that arrays. That fails because but it fails for a different reason. Through the generation stage, but we don't get through the main part. Can I return arrays in this? Let's thingy returns an array of int 32, int 64. Back to thingy, make it return e. We'll just make it 64 and change that and change that, and that's 64. Guy build guy. I type. Nice. So that's fine, and that breaks actually, and that is because Go and Jai's slice types have a different layout, so things break. Try to convert between them. However, if I now do, so we actually need a, so say if return type, yeah, this should have caught it. Did I wrong thing? Because this generated that array of out type. And we really just shouldn't have arrays, period. No, we can. If they're a fixed size, that's fine. All correct. My brain might be mush right now. Boom. Classic or negate. Yeah, why is that? Oh, because it's going to be a pointer. Duh. Okay. So I kind of need to check something. So when we're doing return types, they do like array cast. Oh wait, no. If it is a pointer on the last return type, it's a pointer. So we're trying to return an array of pointer to an array of right, because this is going to generate, this is like changing the type to this, and then we're still returning that. That's also bad. I don't feel like we should do that. That's kind of a foot gun. Maybe I instead, I mean, decisions. If I do this, then I could return like ret.data like that, and that would do it. That would be correct. But that feels really wrong. Yeah, I don't like that at all. So I'm just going to block that. This is also not supposed to be a general thing. This is really just for me. So I don't really care about setting that restriction on myself. Info pointer, ret type, assert, pointer dot pointer 2 dot type not equal to array. Cannot return arrays. Arrays are not. Boom. There we go. All right. And that's good. So that's the failure case right there. I'm going to call that good. Right? We are now auto generating C call or like C calling convention procedures from just Jai code. We literally just call CT generate C export, and yeah, I guess this is technically auto generating like C bindings, kind of how this is, but like not really. Yeah, hopefully you all enjoy this. This is a really fun time. I'm glad it is now done, and talk to you all later.